Thank you. Excellent. It's so good to see everybody early in the morning on Saturday, only in a PyCon conference. So I have a brief talk. I don't think I've talked for 5 minutes in a long time, so we'll see if I can do it. I want to talk about a little project I've been working on for about 6 weeks, off and on, about a compiler for Python. Now, there's a lot of those out there. Other people have talked about it before. But this is for NumPy users, people that are currently using a whole load of C extensions and a whole lot of code to do their data analysis. And sometimes they want to be able to write Python code that goes fast. Not all the time, doesn't matter if it's all fast. Actually, NumPy is pretty fast in a lot of cases. But there are occasions they want to write loops, and they want it to go really fast. PyPy doesn't cut it for us. It doesn't extend enough. So, what do? There's a little project that's starting that basically can do dynamic compilation of Python code. And there's a lot of places in the NumPy runtime where a little function pointer that is machine optimized would come in handy. And you take Python code, stick it through this dynamic compilation, and stick it into a runtime like a universal function for NumPy, maybe fancy indexing, fast indexing, maybe memory filters, maybe text readers with an I/O transformation that can happen at C or at machine speeds. SciPy also needs a Python compiler for things like the optimize module, for callbacks, for integration, for ordinary differential equation integration, for special functions that you want to write in just Python instead of using old Fortran code, ODE integration, and then writing more of SciPy at a high level. The phenomenon I want to point you out to is that Cython, which is basically decorated Python that compiles to C code, is in active use in the scientific Python computing community. Everybody uses it. And the reason is because they want to write their stuff in Python and have it go fast. There's a lot of that we can do with just a Python compiler. So Numba, I just want to introduce Numba. It's a small project. It's not ready for prime time. If you just want to be a user, come back a little later. I'm mainly pointing this out to people who want to get involved and help develop it. This replaces bytecode on a stack with a simple type inference. It translates to LLVM using the remarkable LLVM compiler infrastructure. It's LLVM Pi. I've resurrected that project. It now works on LLVM version 3.1, and it's all in GitHub. It uses the LLVM to do code gen and gives you back a C-level function pointer that can be inserted into the NumPy runtime at multiple places. And we're going to be modifying NumPy to allow it to receive more and more function pointers that it can use. And so it's NumPy and SciPy aware. So the basic picture looks like this. A Python function goes through LLVM Pi. There's a bytecode translator that converts it to machine code. Now the reason LLVM is because all the industry is using it as an intermediate representation. NVIDIA's new compiler works on an LLVM tool stack. Intel's OpenCL compiler works on an LLVM tool stack. Apple, of course, uses CLang, which produces LLVM code. So you have this plateau of code reuse at the very low level using LLVM. So it's a great place for C extensions to also produce LLVM from their Python code. So what does it look like? Something like this. You have a sync function. Let's say it's got this if statement inside of it. The vectorize essentially produces LLVM code. If you've never seen LLVM code, there's an example of what it might look like. This never gets printed out. What that gets, the code gen takes that LLVM code that's translated from the Python bytecode and produces something that can go really, really fast in a machine. This example, for example, there is a sync function in NumPy, but this one's 3 times faster because it compiles to machine code. The sync function also uses compiled loops in machine code, but because of the memory overhead, it's a little about 3 times slower. Another example of the kind of thing we want to be able to do, take a simple 2-dimensional convolution filter that's written in Python, but with the compile syntax, those for loops are all translated down to machine code, and you have that simple multiplication by an image. That multidimensional indexing is done with get element pointer and LLVM, and you end up with a very, very fast code that works just as fast as any of the Cython or the Weave, or even a little faster. Especially once the LLVM code gen takes advantage of things like the PTX backend, which NVIDIA is putting into their LLVM backend to go into the GPU. So this is just sort of a nice place to play. This is, I think, a vision of a software stack future which works very, very well. You have little mini DSLs or domain-specific languages at the high level, which all use Python as intermediate representation for high-level library generation. And then we need a high bandwidth communication down to LLVM so that other people who are using, so that basically C++, C, Fortran can all become little domain-specific languages on top of LLVM. And we can rely on the hardware vendors to optimize code gen for that low level. It's not difficult. It's pretty simple, pretty straightforward. It's the kind of thing that I think the NumPy and SciPy community would really benefit from, and we love it. Everybody I talk to who uses NumPy and SciPy that really wants to be able to do fast code on occasion, they're really excited about this. I'm pretty excited about it too. It's a really fun project. We are seeking developers, people that can get involved in it. If you are a compiler writer, or you just love to play with code gen and translation techniques, it's a great opportunity to do something that has high impact for a lot of people in the scientific Python community. So that's what I'm here doing, is talking about it for people interested in getting involved. And look for us in 3 to 6 months for actually using it to solve your problems. Thank you.
All right. Next up, I'd like to introduce Chad Whitaker talking about ihasamoney.com.
Check, check, check. Microphone check, 1, 2. We're good? All right. Let's get that there, and then let's do. We live. Play. And gonna. All right. iHasAMoney. PyCon! Woo! Yeah! All right. iHasAMoney. What I do with it. My name is Chad. Managing my money is very unimportant to me. It's not that I never want to do it. It's just that I want to spend as little time as possible on it, like 1 hour a month, okay? So what do? Anybody ever seen Mint.com? Okay. If you raise your hand, have you seen Mint.com? Do you use it? All right. For those with your hands down, here's how Mint.com works. It's a personal finance application. You give them your bank passwords. They store them in clear text. Then they screen scrape your bank's website, sell your data to advertisers, and give you ads wrapped in pie charts, okay? What? You know, how is this not a scam, right? Like, where's the value to me as the user in Mint.com, okay? Now, there's some justice in the world because the founder of Mint is now the vice president of product innovation at Intuit, which I think is a punishment that fits the crime. But I'm still stuck. iHasAMoney. What am I going to do with it? How do I fit money management into 1 hour a month, okay? So I built a web app. iHasAMoney.com. Personal finance for geeks, okay? And I'm going to show it to you here. It's going to be hosted locally because I don't trust the network, but you can go to iHasAMoney.com and see the thing itself, all right? So here's what it looks like. Let me get my mouse on the right screen. Okay, here's what it looks like. The first thing you'll notice about it is that you're not, come on, where are you? You're not allowed to use your mouse. Okay? You navigate the thing with the keyboard. You use J and K to navigate, woo! Right? J and K to navigate your transactions on the left. You use D and F, actually, to drill down into your categories on the right. Okay, and then so I'm going to go to uncategorized. And let's see, so I want to categorize something. So I hold S as a quasi mode. Now I'm using J and K, and it's giving you, so iTunes is going to be entertainment, Walmart, you know, who knows, that's gifts, I don't know. The Gap is clothing, Comcast, where does utilities, there's the utilities down there. So this is how I categorize things. So I try to optimize the UI for categorizing things, you know, and then I can drill down, and now I can go up to utilities, and I see my Comcast in there, right? So that's the state of the application right now. The idea is to add more columns to that summary table on the right so that you can get things like budgeted versus actual this month versus last month and stuff like that. You know, tons more features can be added, automatic categorization. Right now, it's a pain in the butt to get data in. You have to upload a CSV that you downloaded from your bank, but at least you didn't give your bank password, you know, with 5 million other people to one company where it's all in the same place in the clear. So anyway, folks, that's iHasMoney. Thank you for your time. Go check it out.
All right, thank you very much, Chad. Next up, I'd like to introduce Moshe Zadka talking about brain hacking.
Hi. I'm going to talk to you about hacking the brain for fun and profit. Now, when you go to technical conferences, not this one, you'll notice that some of the talks are really bad. And the problem is that they're not bad for any good reason, right? It's not like the speaker is not knowledgeable about the content. It's not like he doesn't have something interesting to say. It just seems that the talk falls flat. And I want to try to understand why it happens and try to see how we can fix it. So the problem is that talks are code, right? But they're code meant for like this weird architecture called, the human brain. And like, we don't have specs for this architecture, and nobody knows exactly how it works, and like it's annoying. Most people like have some kind of intuitive understanding of how to write code for this architecture. The range of quality of that intuition varies a lot. Most programmers have very little. But what we do know is how to take technical specs and use them to write code for new architectures. And luckily, lots of people are trying to reverse engineer the architectures, right? We have evolutionary psychology, we have cognitive science. People are trying to understand how the brain works. We can use this. So people are storytellers. That's the first thing you want to know. So people respond much better to an implausible story rather than to plausible evidence. Lots of experiments show that. So what you want to make sure is that your talk tells a story, right? Don't show them lots of evidence. Give them a narrative. In case you're wondering, the narrative for this talk is kind of the hero's journey. You start out with a problem, you collect the magical items, you slay the dragon. It's awesome. And the next thing you want to make sure is that they care about it. Now, people don't care about code. Even programmers can't manage to care as much about code as this. I'm betting you're all looking at this, not? Right? Right? Because these are babies. People care about people, right? So instead of telling them about code, tell them a story from your life, right? I was in this talk where the first story was about someone's first day at his job and the challenges he faced. That glued the audience to the seat, right? It's a relatable story. You want to know what happened next. So you want to make them care. Then people are visual creatures. If you show them the solution, like what you're going to say on the slide, they will read the slide. However, the slide is not a person, they will not care about the slides. When you make sure that the slide shows them a puzzle, like something that will tease their curiosities, then they'll focus on you, because people are puzzle solvers. They want to know the solution. And the last thing to remember is that hacking is a skill, not knowledge. So just knowing all these principles in theory is not enough. Just like in Python, you don't get good by just reading like the big core Python programming. It's an awesome book. But you don't get good by Python by reading it. You have to practice. You have to write lots of code, see what works, see what doesn't. And I hope that you all start doing that, and we'll get much better talks. Thank you very much.
Thank you very much, Moshe. Now it's my pleasure to introduce Dr. Brett Cannon, speaking about Python 3 on PyPy.
Morning, everybody. So, as Noah said, my name is Brett. I'm one of the core developers on Python, and I'm here to try to let you guys know that Python 3 is alive and well up on the Python package index. And just before I start, is PyPI, not PyPy, the VM, or PyPy, or anything like that. It's PyPI. Anyway, back in February of 2011, the PSF sponsored me to create a website called py3ksupport.appspot.com, which is, if you follow my blog, I completely redesigned in the last few months. And basically what it currently does is it tries to figure out roughly what the top 50 projects are. It's based by basically taking the latest version of a project and then calculating its download total divided by the days available per file that it has uploaded, and just use that as kind of a popularity index of who basically the top 50 projects everyone seems to care about is. So without further ado, let's have a quick look live of how it looks. So roughly about 54 to 58% of the top 50 projects have already been ported to Python 3. The reason it's a range is the 54 is definite and the 58 is maybe. I personally hand curate the top 50 projects to make sure that if any project is ambiguous on whether or not it supports Python 2 or Python 3, I personally do the Google search, look through the mailing list, and try to figure out if they're actually actively, not have tried, installed, or whatever, but have actually done the work to do a port. So for instance, Django's listed as under development because Vinay Vajip has actually done a full-on port that he keeps up to date that runs on Python 3. It just hasn't officially been moved over as the official version, but it is actively usable and being worked on. And as you can see, there's actually a lot of projects already on Python 3. There's some red. Unfortunately, Ian Picking doesn't update his projects anymore. So that's why there's some chunks of red on there. But otherwise, there's a decent amount. As I said, at least 54% and up to 58, depending if you count Selenium and Django as ported, are already over. And as you can see, there are links directly into PyPI. Also the details, for instance, of what I have, whether it's on, how many downloads there are, total downloads, when I last updated the data, which I update daily. I pay the $9 a month to App Engine for it. And then I also give a metadata rating on an app's metadata, which I'll cover in a second. So, what does all this mean at about 54%? Well, I honestly think it's a pretty good place to be. When we started Python 3 and launched, way back in December of 2008, we said we were hoping to have roughly a majority of the community moving over in 3 to 5 years. And we always admitted 3 years was our major stretch goal, right? 5 years is probably what we expected everyone to really start moving over. Not the whole community, obviously, because no one ever always will, but at least have a majority moving over. And we've already hit 54% of the top 50. So I'm pretty happy with that. I do make a plea, though. I don't exactly love spending my free time going through the top 50 projects and updating their metadata for them. So if you do manage to maintain a project up on PyPI, please, please, please add a line in your Trove classifiers about what language you support. Even if it's just saying you support Python 2 or Python 3 generally, that's helpful. But honestly, for your own users, it's great if you can specify the specific version, like 3.2 or 2.7 or 2.6 or whatever, because it makes it easy for them to just look at the project to go, oh, that supports Python 2.6. I'm on 2.6, fantastic. Or I'm stuck on 2.5, it doesn't support 2.5, sad face, whatever. These people, though, are in the top 50 and don't have that in there. So I'm publicly shaming them a little bit. I don't think Ian's here, but if Mike, Vitaly, Aaron, Benoit, Mitch, Mike, Armin, Jeff, Andrew, and Andy, who get at least italics because they at least specify that they are a framework with Django, so it's kind of implied, but still it'd be nice. Ruby, and a whole bunch of other people would please update your Trove classifiers. I'd really appreciate it. And if you haven't ported over yet, there is a porting how-to that we have up on docs.python.org. Recently, we added back into Python 3.3 support for the U prefix to make it even easier for you guys to deal with your Unicode string conversion issues between Python 2 to Python 3. So we're still working to make it easier for you guys to do your ports. So please, 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 do take the time to do your ports. We're making it still as easy as possible if you use 2 to 3, if you do a single base port that supports syntactically 2 and 3, or if you do the branching, whatever. We're doing what we can to make sure you guys are ported without rolling back the clock on the new features. Anyway, thanks a lot.
What? Thank you, Brett. And next up, our final lightning talk for the morning, Luke Gosling talking about Python on ebooks.
All right, thanks. Can you hear me? Yeah. All right. So I managed to get the Python interpreter running on iBooks without jailbreaking my iPad. So you can use this for just running the interpreter in an ebook. So when you have your iPad, you can actually run Python code on it. And this is also great for having any sort of instructional textbooks where you actually want to teach people how to do things with Python, and you want to be able to use the iBook store for distribution. Of course, this is a little bit difficult. The iBook store has no way to run arbitrary binaries, so it's kind of hard to run the interpreter on it. But you can embed media, presentations, HTML widgets, and 3D models. So the HTML widget method is actually a way that you're able to run the Python interpreter inside of an ebook. So the way that I've managed to accomplish this is that you have the Python interpreter, the JavaScript implementation of it, inside of a Dashcode HTML widget, inside of the iBook wrapper. And you're good to go. So it's CPython compiled from C to JavaScript using Emscripten by Alan Zakai. The input and output is HTML elements. It is compatible with the iPad on-screen keyboard. 4.8 megabyte overhead, which is not that bad considering basically what the code looks like. And the big thing is that it runs on vanilla iPads, starting with the first gen. iOS version 4.2 and up, and iBooks version 2 and up. And if you find me, I will show you this running on my first gen iPad. I don't have the 3 yet. The downside is that you basically, every time you want to have a Python interpreter, you have to embed it. So basically, right now the issue is that if you want to have two places inside of an ebook with the Python interpreter, you have to embed it twice. So I'm going to see if there's a way to deduplicate this. Also, potentially having syntax highlighting and some other goodies inside of the ebooks would be nice as well. I don't think there's time available for questions, but the code will be available within a few days. Again, if you come find me, I can show you how this is running on my plain iPad. Thank you.
All right, thank you very much, Luke, and thank you everyone for coming to the morning lightning talk sessions. I hope to see everyone back here at 5:30 tonight for the evening sessions. And if you're interested in giving a lightning talk, the sign-ups for tonight and tomorrow morning will be up shortly later today.